Hello, exceptional students of Mrs. Whitney's. I have my trusty sidekick, Brita, with me, and any squeaking that you hear will be from her. She is playing with a toy, and she is very proud of herself. So welcome to section 5.3, Writing and Solving Proportions. So we've talked a bit about what makes a proportion, and now we're going to actually write them. And this really isn't a humongous deal. You just have to be able to keep track of things. That's sort of the trick to this. So one way to write a proportion is to use a table. And if we talk about the buying ringtones, so I don't know if this is really such a big thing anymore, but you used to be able to buy a ringtone. So last month we bought 2 ringtones and it cost $6, and this month we're going to buy 3 ringtones and we don't know how much money that's going to cost. So we can write a proportion. And one way of thinking about this is literally taking a line, making the proportion of 2 ringtones to $6, which is equal to 3 ringtones to some unknown amount of dollars. And that's what they used here in this case. So we wrote them. It was 2 ringtones for 6, 3 for X. And things to keep track here is that the ringtones are both in the numerator and the dollars are both in the denominator. So the denominators have the same units and the numerator has the same units. That's one way of writing it. The other way of writing it is think about taking that table and taking it like this and going and switching it up like that. So we're comparing ringtones to ringtones and dollars to dollars. The only tricky thing about this is keeping track of the fact that this is 2 ringtones for $6, which is last month's, versus 3 ringtones for unknown amount of dollars, which is this month. So the only thing tricky with this is you have to keep track of the fact that you're comparing like to like. Remember how we used the cross product to determine whether or not something was whether or not it made a proportion? Well, think about this in this case. If you multiplied 2 times x, you would get 2x. And if you multiplied 6 times 3, you would get 18. So if I did the cross product, it's 2x is equal to 18. If I did this correctly, these cross products should be the same. Well, 2 times x is 2x, and 3 times 6 is equal to 18. So that sort of proves that it doesn't matter how you write that as long as it's consistent and the cross product ends up being alike. That's a lot of explanation. Let's actually put this to work. So we're going to write a proportion, and we're going to use this black bean soup. So a chef increases the amount of ingredients in a recipe to make a proportional recipe. The new recipe has 6 cups of black beans, and it wants to write a proportion that gives the number X of tomatoes in the new recipe. So we're going to use a table to organize this. So in our old recipe, we had, what are we trying to compare? We're trying to compare black beans, and tomatoes. So these are the two things that we're trying to compare. So in this recipe, I have, the old recipe, and I have black beans, and the new recipe, and I'm comparing this to, I don't know why this ends up so crooked. We're comparing those to tomatoes. So in the old recipe, we have 1.5 cups of black beans. So old recipe, black beans is 1.5 tenths or 1.5, and 1 tomato. In the new recipe, it has 6 cups of black beans. So the 6 would go here, and we don't know how many tomatoes. So we're going to write the proportions. Remember I said think about this as just drawing your line to separate the proportion of the ratio, another line here. So I would write this as 1.5 black beans to 1 tomato is equal to 6 black beans and some unknown. And that's how you would write that proportion. You could also write it a different way. Remember, I said you could compare 1.5 to 6. So we're comparing black beans to black beans. And now we're going to make sure that this is old and old. So 1 tomato to an unknown amount of tomatoes. Remember, you can check to see whether or not the cross product is the same. Now 1.5 is x, and 6, 1.5 x, and 6. So those two proportions actually would result in the same. So you could write it in either way. So let's try another one. Writing a proportion. You can buy 3 bags of candy. So, sorry. I don't know what happened there. I do know what happened. Where's the undo? I held down a button. Sorry. Okay, let's try this again. So we have 3 bags to $15. This is another way to keep track of whether you're comparing like to like, is to label your units. So what proportion gives the cost, C, for buying 8 bags of candy? Well, cost has to go with the money. And 8 bags. So 8 bags. If you label things, it helps you sort of keep track of like to like. Be careful not to write it in order. If you wrote 3 bags to 15 and C to 8 bags, you wouldn't be comparing like to like things and you wouldn't get the same result. So labeling does help you. All right, writing a proportion with percents. So it says write a proportion to find out how many points a student needs to earn on the test to get a given score, where the test is worth 60 points and the score is 80%. Remember, we can rewrite 80% as 80 over 100. Well, there's half of our ratio, right? Or half of our proportion. Here's one ratio. So it's 80 points, or it's 80%, and 100 is your total percent, right? So if I had a test that had 100 questions, I got 80 of them correct. So this test is worth 60 points. So that's my total. So think of this bottom bit as the total. And this is the number correct. So I got 80 correct out of 100. So we need to know how many you need to get right out of 60 total so that I would get 80%. And that is it for this one. So good luck and thanks for watching.